Hello again. What I'd like to do this time is problem 61. This is also a very classic business problem, business application of calculus, and it's just like the other problems you have 62, 63, 64. So in 61 it says, a baseball team plays in a stadium that holds 55,000 spectators. Okay, let's start writing down. So we have 55,000 spectators in the stadium, or possible spectators, let's put it that way. The ticket price at $10, the attendance had been 27,000. So for $10, we get a 27,000 attendance. Okay, that's not good because we've got 55,000 spaces, right? 55,000 seats. When ticket prices were lowered to $8, so when they were lowered to $8, attendance rose to 33,000 spectators. Okay, so the first question, find the demand function, assuming that it is linear. Okay, so what do they mean by that? The demand function is a function that relates the price to the number of tickets sold. So basically, it's a function where price is the y variable, and tickets, number of tickets, is the x variable. So y is a function of x. So it's a function, it's price as a function of tickets sold. And we see that if we want to sell 33,000 seats, we better set the price at $8. If we don't care and want to sell 27,000, that's good enough, then we set the price at $10. So this is a way of putting in how many spectators we want and then getting out what our price should be. And this is what they call the demand function. Okay, so, and notice they say the relationship between the two is linear. Now, that means that there's a constant rate of change. What's the difference between 27,000 and 33,000? It's an increase of 6,000, right? This is a decrease of $2. So it looks like for every 6,000 spectators, I need to decrease my price by $2. Or for every 3,000, I want to increase my spectators by, I better lower the price by $1. Okay, that's what they mean by this is linear. So you can reason out the relationship between the price and the number of tickets sold. You can reason it out, or you can do an algorithmic way and say, well, this is a line. The relationship between P and X is a line, and my Y variable is the price, and my X variable is the number of tickets. So I can get the slope and put it in point slope form and get the answer. Or I could just reason it out. Let's see. Let's say I start at a price of $10. Okay. So I know that for every $2 decrease, I go up by 6,000 spectators. Right? So for every $2 increase and for every $1 decrease, I go up 3,000 spectators, right? It's a ratio. Okay, so I can see, how much do I have to go down? Well, X is the number of spectators I want. Okay, So let's say I want to go beyond the 27,000, and so X is the number of spectators. I'm going to look at the difference between the X I want and the 27,000. Now, I got to multiply by something. So if I have a difference here of, let's say, 6,000, like I had here, I've got to go down $2, because it's for every 3,000 spectators I go down $1. So what I need to multiply by here is 1 over 3,000. Because I need to say for every 3,000 I want to go up. So for every 3,000 that fits into this difference, I need to pull the price down by $1. So this is what our demand function is. Let's say you don't like that. It's okay, there's another way to do it. There's always another way to do it. We can do it this way. We can say, okay, straight. So this is X, this is Y. So 27,000 X, Y is $10. 33,000 Y is $8. What's my slope? My slope is change in Y over change in X. Okay, so I do the math, I'm going to get negative 1 over 3,000. That's my slope. That's how much I have to go down for every 3,000 spectators. Okay, then I put it in point slope form using, let's say, this point. Y minus 10, so I'm going to add 10 over there. Y minus 10 equals slope times X minus 27,000. That's exactly what we have here. So if you like to look at it this way, look at it this way. If you're happy with just reasoning it out, that's fine. But this is our demand function. So let's go to the second part of it. The second part says, what should the ticket price be to maximize revenue? Okay, so I'm going to leave my demand function there. And this is going to be part B. So I want to maximize, it says I want to maximize revenue. That's how much money I take in. Well, how much money I take in would be the number of tickets times the price per ticket. This is the price per ticket. So my revenue, the number of tickets is X. So my revenue would be X times the price. Okay. So that's my revenue. I want to maximize that. Well, I find the derivative, set it to 0, and see what X maximizes it. Okay, so let's clean it up a little bit. I'm going to multiply this out. So this is going to, and multiply this. So I'm going to get 10x minus x squared over 3,000. So I'm going to multiply this times this. Then I'm going to multiply this times this. Then I'm going to multiply the negative x over 3,000 times x. And then the negative x over 3,000 times negative 2,000. Which is going to be x over, what's 3,000 into 2,000? That's 9, isn't it? So 27,000 over 3,000 is 9. And x times x, and we distribute that. So we get 19x minus x squared over 3,000. Notice that's a quadratic, and it's going down. So we're looking for the maximum. So we take the derivative. So the derivative is going to be 19, bring the 2 down, so all we have to do is bring the 2 down, decrease the exponent by 1. So I'm going to rewrite this as minus x over 15,000. 1,500, excuse me. Because I brought the 2 down, 2 goes into 3,000 and leaves 1,500. Okay, so now I have to set that to 0. So when I set that to 0, I'm going to get 19 equals x over 1,500. So x equals 19 times 1,500. I don't know what that is. 19 times 1,500 is going to be 2850. 28,500, excuse me. 28,500. Okay. So the number of tickets I need to sell, I know this is a maximum because I know this is a quadratic and it's going down. It's concave down everywhere. Notice if I took the second derivative here, I would get a negative 1 over 1,500. So it's always negative. It's always concave down, the function is. So I know this is a relative maximum and an absolute maximum. So at 28,500 tickets, I would have the maximum profit. Okay, now maximum revenue, sorry. So the question is, how should ticket prices be set? There's the answer. The ticket prices, so we want to sell 28,500 tickets. Okay, so wait a minute, we got to go to the price, back to the price function. Because they want to know what price we should set to sell that many. Okay, so this part is the price function. So the price at 28,500 would be 10 minus 1 over 3,000 times x minus 27,000. Okay, so 28,500 minus 28,000. Sorry, 28,500 minus 27,000 would be 1,500, right? Okay, and this would be 10 minus a half. So, which would be 9.5. So you should set the price at $9.50 to maximize the revenue. Okay, that should help you with problems 62, 63, and 64. They also have a great example in the book. See you again.